Good evening and welcome to tonight's clinical seminar entitled Fight, Flight, Freeze. This is part one of a two-part series on the limbic system. Part two will take place next month. We're going to get started now with introductions. For those of you who don't know me or are new to CMHRC, my name is Elizabeth Errico, and I am the Executive Director of the Children's Mental Health Resource Center. Our mission is to provide guidance and resources for the early identification and management of mood disorders such as bipolar disorder and its newly identified phenotype that has been dubbed fear of harm. We fulfill this mission through various services that we offer to both families as well as mental and physical healthcare providers and educators. We work with families and providers to understand the diagnoses, their unique presentation in children, and how to access not only a correct diagnosis, but also effective treatment for childhood onset of these mental illnesses. We work with educators and families around making sure that children's mental health needs are met at school. We work with families and their communities to ensure that their needs are being met in the community at large. We've developed a web app to help parents track the symptom presentation that they see in their children. We have various types of membership. We have other types of services, all of which you can find out about on our website, cmhrc.org. Now, October and November each year is when we run our annual fundraising campaign entitled Giving Thanks. This quote is from a family in our community who expressed their appreciation for the work that we do. She said, "We give thanks because reaching out to CMHRC about my daughter has literally changed our lives for the better. Talking with CMHRC, attending support group meetings, allowing our counselor and psychiatrist to talk with CMHRC experts was the best thing we ever did." CMHRC's proactive, individualized, and compassionate approach was instrumental in enabling us to pursue life-altering treatments. Thank you. These comments are usual for us. We provide supports that fit into a gap in services that families are able to find in the community at large. And we keep all of our rates either free, like this educational series of clinical seminars, or at below market rates so that as many people as possible can access our programs and services. In order to do that, we subsidize the cost to families through charitable donations. Those donations come from providers, they come from families, they come from educators, they come from anyone in our community who recognizes the value of what we provide and is interested in helping others access our services. You can make a gift to our Giving Thanks campaign on our website, cmhrc.org/donate. And any gift that is given before our campaign officially kicks off on November 1st next week is subject to a one-to-one match. So you will be doubling your gift by making a gift between now and November 1st. Now, tonight, as I said, we are going to be talking about the limbic system. We are going to focus on understanding the limbic system, how it functions, and we're also going to explore the reality that many limbic system responses can, from an external standpoint of observation, be very similar to behaviors that we typically think of as being psychiatric symptoms. Part two next month will focus on how we can take what we know about the limbic system and the impacts of the amygdala, hypothalamus, and hippocampus, and use that knowledge to help us understand how to help de-escalate and re-regulate when children become dysregulated, especially with the fight, flight, freeze response, and overall how we can use our understanding of the limbic system to promote and increase well-being. During tonight's presentation, we ask that you hold your questions or put them into the Q&A box. We will answer them at the end. So please don't raise your hand, simply put your questions into the Q&A and we will go through it and make sure as many questions as possible get answered before we run out of time. That said, if you are interested in a certificate of completion for tonight's presentation, tomorrow when you receive a follow-up email from Zoom confirming your attendance, in there will be a link to request a certificate of completion or certificate of attendance if you are a family member, and we will be able to provide that to you for a $5 preparation fee. Again, check your email tomorrow for an email from Zoom and the link will be included. Now, tonight I want to welcome Jennifer Sevick. She is CMHRC's clinical director. She's a licensed independent social worker, and she is here with me tonight to talk with you about the limbic system. So, Jen, we both know from our experience working with families that the traditional cognitive behavioral approaches, they just don't work when we're treating kids who have mood disorders. And I'm hoping that you can start out by talking us through that a little bit.
Yeah, sure. So, Elizabeth, traditional clinical cognitive and behavioral approaches, they often aren't effective treatment interventions for children and teenagers living with mood disorders, as you've noted. Difficulties resolving symptoms, and which are often identified symptoms as like, quote, problematic behaviors. These leave parents, teachers, providers frustrated and really at a loss about which kind of strategies that they need to try. And so behaviors are really just observable symptoms of physiological and biological causes. So tonight we'll be discussing these observable symptoms that are rooted in limbic dysregulation. And tonight we will also discuss what the limbic system is and the key structures involved in symptoms to mood disorders. We will identify symptoms of bipolar that are often influenced by a dysregulated limbic system, learn why mood disorders are thought of to be a metabolic disorder, and how energy actually impacts the limbic system. And there's actually quite a bit of controversy over what the limbic system is, what parts of the brain actually make up the limbic system, and to compare to other systems in the body, such as the nervous system, the limbic system actually has remained something of a mystery because it was more difficult to research.
So, Jen, I'm going to stop you there and ask why that is. Why is the limbic system more difficult to research?
Well, doctors and researchers could directly observe, like, say, for instance, what the spinal column does. They could observe what interventions worked, what didn't work, when a toe could wiggle. Doctors and researchers can more easily identify what is wrong and how to address it. And it can be assessed which nerves or muscles or ligaments are damaged, and one of interventions are the most effective in that treatment plan. But when it comes to emotions and behaviors, it isn't as easily obvious about what parts of the limbic system are at work. And so this knowledge or this area is rather new compared to other structures and other systems in our human bodies. So it also means that this is also a new and exciting frontier in medicine and research. And due to ever increasing advances in neuroscience, the areas of the brain that are included in the limbic system have changed many times over the years. The roles and functionality assigned to this system has also undergone multiple shifts.
Okay, so what is involved in the limbic system? What does it do?
Yeah, originally the limbic system was defined as part of the brain that solely just regulates emotion. And now the limbic system is now thought to assist in various processes related to cognitive conditions and including spatial memory, learning, motivation, emotional process, and social processing. So that's a lot of stuff.
It sure is.
Yeah, in other areas of the limbic systems play a role in long-term memory, such as long-term memory, temperature, heart rate variability, sleep, sexual stimulation, hunger, and cardiac rhythms. So even the evolutionary story of the brain and how that limbic system responds to real or perceived threat has changed considerably over the years.
So you're talking about circadian rhythms, sleep, hunger, things that sound like they're connected to metabolism. And we know that there's a lot of research right now going into talking about bipolar as a metabolic disorder. Lots of folks ask us about that. Can you talk a little bit about what that means?
Yeah, so according to the Harvard School of Medicine, the brain uses over half of all sugar energy, which is glucose, in the body. And in recent years, researchers around the world are shifting their thinking from unipolar depression and bipolar as what we call mood disorders to understanding bipolar and depression as really mitochondrial disease or really energy disorders. And it makes sense that then if bipolar is an energy disorder, that the areas of the brain that require the most energy are significantly impacted by mitochondrial disease.
And you're talking about the limbic system there, right?
Absolutely. So the limbic system requires more energy than any other structure in the brain, and it's responsible for processing hormones that regulate the majority of the system in the body in general. And when the energy is not processed efficiently or effectively, the parts of the brain that need the most energy will be impacted significantly. And when this happens to the limbic system, that leads to symptoms that we see as mood disorders.
So you're saying that mood disorder symptoms are coming from dysregulation in the limbic system.
Exactly. We can physically observe some of this dysregulation that is occurring in the limbic system.
What do you mean by physically observe?
Yeah, so let's look at what people call behaviors. Instead of looking at behaviors as willful choices or decisions, we can observe, we can listen, and we can ask more informed questions that will give us more insight into if these are biological responses and not actually willful behavior. Then this knowledge that limbic dysregulation is part of the disease process helps us to understand why symptoms occur the way they do in the first place.
So, Jen, this is something that we talk about a lot in our palliative parenting class, where we help parents understand the difference between intentional behaviors and involuntary symptoms. And a lot of parents talk to us in the class, and a lot of educators that we work with in our school advocacy program, and even a lot of the providers that we talk to in our professional discussion groups, talk about symptoms as though they were behaviors, and parents will complain, and teachers will complain about children who can't follow instruction. But we're really talking about that quote behavior as a symptom, not a choice. And that and others are actually coming from limbic system dysregulation, right?
Yeah, so instead of thinking that our child is doing this on purpose or they're misbehaving in a classroom on purpose, isn't it really nice to know that this is not manipulative or attention-seeking behaviors, that there's actually a biological reason for this? And in fact, a lot of us, even those who aren't living with mental illness, we can become dysregulated, and our limbic system is really the loudest system in our body. So knowledge about why people get dysregulated, and it really goes a long way in how we can respond to other people when they're in crisis. And so some of you may actually have heard of what is called the triune brain theory. It's used by many practitioners in the field to describe the fight, flight, freeze, dysregulation, and trauma response. And unfortunately, it's really outdated. So its popularity was conceptualized as like three layers consisting of the reptilian, mammalian, and the neocortex, and really just evolving neatly on top of each other.
So before we talk about why it's outdated, maybe for those in the audience who haven't heard of this before, you can explain a little bit more about what it is.
Yeah, so the theory goes something like this. The brain evolved in three main stages, and the most prehistoric part of the brain, what people commonly refer to as the lizard or the reptilian brain, is responsible for going into that survival mode so that when it feels threatened or overwhelmed, it's known as the fight, flight, or freeze. And during this state, the prefrontal cortex is thought to be unavailable or offline, causing reasoning and logic to just not be available to access. And when the oldest part of the brain takes over, it floods us with emotion, leaving really only the most primitive or primal instincts that are geared towards that, of course, that fight, flight, freeze, fawn, or feign that people talk about.
Mm. So now you said this was an outdated theory. What's wrong with it?
Well, the first issue is that the regions of our brain did not actually evolve independently of each other. All areas of the brain evolve simultaneously over time, not actually in successive stages. So there's that. And another issue is that structures in the brain do not appear to function independently of each other. So during emotional responses, there is an activity in there is activity in the amygdala, the limbic system, but honestly, there's also activity in the cortical areas of the critical areas of the brainstem as well. And we tend to think of those areas as just not being able to be able to access. So additionally, emotion and cognition are not independent events. Rather, they're interrelated functions and they're all working together in concert. So the truth is, there's actually really no primal or primitive part of our brain that is dedicated to that fight, flight, or freeze response. And additionally, no parts of our brain are just considered offline.
So if there isn't any sort of reptilian brain that we revert back to when we're in danger, then what exactly do we think is happening with the fight, flight, freeze response?
So the body, including the brain, is more like an orchestra, with each part acting in concert with each other. Think of the limbic system as a section of the orchestra, with each part as an instrument that may play multiple sounds or multiple roles within that orchestra. If any instrument is out of tune, if it's out of sync, then the entire sound or the entire feel of that piece being played is going to be very different than when the instruments are all playing in sync with the rest of the orchestra. So let's put it this way. If we think of the amygdala, for example, as drums, and we hear those drums banging really loudly, we can't actually hear the other instruments that are being played. And so that banging of the drum, it overshadows everything else, causing the entire orchestra to really be out of sync. And if it isn't the other instruments, if it isn't that the other instruments aren't playing, it's not that they're not there. Of course they are there. It's that the drums become the only part of that orchestra that really could be distinguished and heard in that body. And so the drums start to act kind of as the conductor, as well as the loudest instrument at that moment in time. And so the rest of the orchestra is really going to be listening to the loudest player, and they're going to follow that lead.
That's a great analogy. I love how it sort of explains that everything's happening at the same time. Can you concretize that and give us an example specifically related to the limbic system?
Yeah, so the amygdala does this thing where it's responsible for sensory input, like it interprets facial expressions, tone, touch. So let's imagine that a child isn't following instructions in class, right? The teacher comes over and puts their hand on the child's shoulder, intending to communicate comfort. But the amygdala is misinterpreting that touch, and it's saying, "Oh, this doesn't feel good. This is highly threatening." And when I say highly threatening, Elizabeth, I mean that that child is looking at that touch as a danger to their life. And I know that's hard to imagine, but that's how it's being perceived in that moment. And that's really hard for people to understand. So at that moment, the amygdala, or going back to the drum, is going to be setting off alarms that drown out everything else, and every other system in the body is paying really close attention to those drums at that moment in time. And then those other structures are going to do what they need to do instinctively when the drums are that loud. And that means feet may pick themselves up and they're just going to run right out of that classroom. Or hands might start to flip over the desk, rip up papers. The mouth might start shouting, even cursing. So those are some ways it responds.
And in each of those examples, the running, the flipping over the desk, the shouting or cursing, you're talking about fleeing or fighting there. Um, um, but really what you're saying is that the body is following the lead of the amygdala, but the rest of the brain is still functioning. Is that right?
Yes, but I also want to recognize how difficult it is in that moment when you're that adult or that teacher, to recognize that these behaviors are really symptoms. They really actually are symptoms.
Right. And it is difficult sometimes in the moment to not take it personally. And we do spend a lot of time in our palliative parenting class talking about how not to take that personally when we think that we're seeing behaviors, but they're actually symptoms. So given what we know, what do we need to do in order to sort of hear the rest of that orchestra so that we can be in sync and be regulated again? How do we get those drums to quiet down?
Yeah, so it's better to understand how the parts of the limbic system and the structures within that system work, and interact in relation to the brain and body as a whole. So, similar to the orchestra, the limbic system is the large scale composition or structure that require a great deal of cooperation in order to be in harmony or homeostasis. And this reframes the idea of it, Elizabeth, from a lizard brain to more of an orchestra really working together. And this helps us to understand more effectively what we need to do to de-escalate and regulate when that limbic system dysregulation occurs.
Okay, so you've mentioned the amygdala, but what are the other parts of the limbic system?
All right, so there's no universal agreement at this time on what the structures of the brain actually comprise the limbic system. The areas of the brain that are currently the most agreed upon at this time are the amygdala, which we've already talked about just a little bit, the hypothalamus, and the hippocampus. And there are others, but for the purpose of this clinical seminar, we're really just going to focus on those three structures. So the amygdala is a tiny almond-shaped structure. It is a paired structure, so that means there are two, and we have one on each side of our brain, and it is located in the temporal lobe. Most people are familiar with fear and aggression being linked to the amygdala, but it really does a lot more. It controls how people perceive other people's intentions, from their tone of voice, from their body language and actions. It also is actually responsible for controlling emotions related to memories and learning through rewards or punishment. And the amygdala is also the one that processes the sensory perception of tactile stimuli. So it is interesting to note that it aids in how the body processes and perceives the socio-cognitive dimensions received through touch. So dissociative symptoms are also associated with amygdalas. And that's a lot of stuff. There was a fascinating study in the rhesus monkeys where the bilateral lesions took place in the amygdala. And it was back in 2003. And the researchers concluded that the amygdala is constantly assessing environments for threats, and that a hyperactive amygdala may play a role in anxiety and other fear symptoms that we see play out in psychiatric disorders. But there are other research studies linking the absence of the amygdala with the inability for primates to recognize and perceive danger, as well as functioning within social groups.
So that is fascinating, but how does that translate to people or to kids specifically?
All right. Well, you know as well as I do that Dr. Dimitri Popoulos and his co-author, Janice Popoulos, wrote in their book, The Bipolar Child, that about 1/3 of all pediatric patients living with bipolar reported extreme and intense fear. These pediatric patients found that their symptoms were relieved by, they weren't really relieved by traditional psychiatric medications that were available. They also exhibited intense aggression. They tended to misinterpret other people around them. They also experienced high rates of threats in their environment. And this misperception to touch, to tone of voice, intentions, and facial expressions, intense fear, and subsequently that aggression, as it was related to their fear, indicated the dysregulation of the amygdala.
So this 1/3 of patients, you're really talking about that Dr. Popoulos and his team eventually identified as the phenotype that they dubbed FOH, or fear of harm, because it was this fear was so intense, and it really makes sense when you think about it through the lens of the limbic system and the amygdala and its misperception of threat. So that's the amygdala. What about the other parts of the limbic system, like the hypothalamus, which also plays a role in FOH? We talk about it a lot in relation to FOH and its symptoms. What does the hypothalamus do?
Yeah, we really do talk about the hypothalamus a lot when we're talking about fear of harm or FOH, and because the disorder at its core has both sleep and temperature disruptions, which are controlled by the hypothalamus. And so, in fact, researchers currently refer to it as thermoregulatory sleep dysregulation disorder. So that's what FOH is from. And so the hypothalamus is a structure deep within the brain that acts as a central coordinating center to manage the hormones that keep the body balanced and homeostasis. It regulates hormones that control internal body functions such as appetite, weight gain, heart rate, temperature control, uh, circadian rhythms, emotions, even things like salt and water balance, and growth. And when dysfunction in the hypothalamus happens, it's going to trigger a response in the amygdala with aggression, fear, and anxiety, which we also know as commonly that fight, flight, or freeze response. And so, in another paper by Dr. Dimitri Papalos and his team, um, which was published in the Journal of Psychiatry and Brain and Science, the researchers reported that among aggressive youths with severe mood lability who frequently fail to benefit from mood stabilization and antipsychotics, there was this underlying thermoregulatory deficit, a specific prodromal sequence, and a unique constellation of symptoms. And for anyone who's interested, you can find this paper on our CMHR's website under the research page.
That's under the free resources tab on our website, cmhrc.org. If you scroll down, you'll see research, and this paper and many others can be found there.
Yeah, and the core feature of actually of dysfunction in the body's ability to thermoregulate, which results in this excessive heat buildup. And the causes of thermal discomfort in even this causes discomfort even in neutral or ambient temperatures, and it's moderate to extreme cold tolerance. So it produces also REM sleep-related problems and parasomnias such as nightmares, night terrors, and even sleep paralysis. So, in other words, temperature and sleep dysregulation due to irregularities, in the hypothalamus contribute to symptoms of aggression, fear, and anxiety. And those are all symptoms frequently observed in individuals living with bipolar disorder. So when we say we can observe them, we can actually see these symptoms happening.
And if anyone is interested in more information on the FOH phenotype, we did a clinical seminar series with Dr. Papalos this past spring in May and June, where he talked about the identification of FOH, the identification of the treatment protocol that he and his team developed. He talks extensively about the sleep and temperature disruptions, and you can find those on our YouTube channel as well. Okay, so Jen, we have talked about the amygdala, we've talked about the hypothalamus. Now tell us about the hippocampus.
Yeah, so the hippocampus is two structures, one on each side of the brain, located in the temporal lobe region, and it's responsible for storing episodic memories, which correlates to fear in the fight, flight, and freeze response. And the hippocampus activates the regions of the brain involved in that fight, flight, or freeze response, which, as we've discussed, are both the hypothalamus and the amygdala, and instructs them to come online. And so when the hippocampus loses control of those circuits, people experience this dysregulation of fear and anxiety, and it's really intense.
It sounds like that might also relate to other disorders like anxiety disorders and even PTSD.
Yeah, it sure does. So the hippocampus retrieves stored information, memories, and even sensorial memories. So where the body has learned that if this is a safe or unsafe situation for them, it also perceives if an unsafe situation, then the hippocampus activates dissociative responses, so that the memory of that traumatic or threatening event is not stored in the typical pathways. Some symptoms of dysregulation stem from complex interactions of hormones across brain structures.
What might be some examples of that?
Fear, anxiety, aggression, memories, perceptions of safety and threat, thermoregulation, nightmares, parasomnias, and sleep disruptions, of course, but also sexual arousal and dissociative symptoms are all examples of those. But the reality is that the structures in the limbic system communicate using complex neural pathways, and dysregulation occurs throughout the brain and body as a result when things go awry. So remember, Elizabeth, we said earlier when we were talking about energy, and if energy isn't effectively and efficiently traveling along these synapses, then those neurotransmitters are not going to be in homeostasis. And because in bipolar, either we have not enough energy or we have too much energy, and that's where we see depression or mania or hypomania.
You're right. This is a framework that's being used by researchers all over the world to examine the impacts of energy or the or energy as the sort of explanation for bipolar disorder symptoms. And as you mentioned earlier, they're looking at it from a standpoint of it being a mitochondrial disease, and that it being a metabolic disease. Right now, we at CMHRC are studying this in children through a study called ketogenic therapy in action, where we are looking at ways in which changing diet to use a ketogenic therapy model could be an effective treatment intervention for children who are living with bipolar disorder. So that is something that we are exploring right now in conjunction with folks all around the world. But so let's bring this back to kids and talk about these interactions across brain structures in relation to kids. So do you have an example of the
Yeah,
limbic
so
system disruption manifesting as something that is perceived to be behavioral?
let's look at something pretty common, which is how it might appear in the classroom setting. Uh, so let's, Elizabeth, go back to that first example that we talked about earlier about the boy who responds unexpectedly to his teacher just, tapping him or touching him on the shoulder. And let's just call him Jameson. So let's say that he's an 8-year-old student and he has been newly identified as living with bipolar and dyslexia. So Jameson comes in from recess and has math worksheets that are waiting for him on his desk. Jameson walks around the room and goes to the sink, and let's say he starts playing with the water instead of sitting and completing the worksheet at the table like he's expected to do. So the teacher notices, of course, walks over and puts her face close to Jameson and asks privately if there's something wrong. And she lightly touches him again on the shoulder. And Jameson then pushes the teacher out of the way, starts grunting, growling, and then spits at her. In most schools, this would earn Jameson the sort of disciplinary action we would expect that. But discipline doesn't stop this so-called behaviors. And I want to note that I would put behaviors in quotes there because after several similar incidents, the teacher attempts to put a reward system in place for Jameson, but he's unable to complete the math regardless of how many rewards that there are in place, regardless of how many consequences that are being put forth. And in the end, he just isn't able to complete this. And of course, more and more things such as like free time and recess are just taken away. And so then what we notice is that Jameson and kids like him all across the country who live with these types of dysregulation continue to have these symptoms regardless of what type of interventions, traditional behavioral interventions that are put in place. And what we see and we hear all the time from people is it just seems this behavior, and I put again behavior in quotes, it just seems to keep escalating.
And Jen, this is a story that you and I hear over and over and over again from families about the fact that their child is dysregulated and none of the traditional interventions that are tried work. And they really they really struggle. But understanding this from the standpoint of the limbic system really can change our perspective.
Yeah, it can when we see it from that it is a dysregulation that is actually increasing their distress. So let's go back and look at what clues that we can take from this situation, right? So when Jameson came in from recess or from gym class, his face and ears are flushed significantly, more than the rest of his classmates, and his hypothalamus is having difficulty regulating his temperature. In an effort to reduce that bodily heat that Jamison is experiencing, he really instinctively goes over to the sink to start splashing water from that faucet on his face, which looks like playing, but for Jameson is really serving purpose. And so next, the hippocampus has stored memories of math being exhausting, long, tedious, really just impossible to complete. And so Jameson starts to feel threatened, and his amygdala is really on high alert at that point. And so the teacher's concern is perceived as anger by him. And it really just escalates the feelings of danger and not being safe. And so Jameson responds by spitting, swatting at his teacher in an effort to protect himself because the amygdala is working really hard and it's working hard out of self-preservation and protecting itself. And so it's important to recognize that Jameson's limbic system perceives this as actually a life-threatening event. And again, we can physically observe this happening. And so at this point, we can observe the physiological symptoms that are really manifesting as, quote, behaviors. And we can see that the student was already experiencing limbic dysregulation. And then the situation just started to escalate through a series of incidences that really, Elizabeth, could have been avoided with understanding what was happening at a physiological level sooner. So small changes in understanding and then making those changes in the environment through appropriate accommodations really can prevent further dysregulation before it just becomes so out of control and disruptive.
Jen, you're absolutely right. There's so many times that we talk about these minor adjustments, accommodations that can be given in order to prevent dysregulation from happening in the first place. And that counts at home as well as at school. But we do know that we can't prevent it 100% of the time. We can't always predict what's going to be happening in the environment or what's going to be happening in these internal processes that kids are experiencing. And so in part 2 next month, we're going to talk about how using the information that we know about the limbic system can give us the knowledge we need to intervene and support de-escalation and re-regulation. But situations like this are happening all the time, everywhere, across the country, in classrooms, countless times every day.
Yeah, and what we hear often too from parents and from teachers and other caregivers is that a simple no can be perceived as a threat and is enough to just spiral these kids out of control. And so, in a child who is living with bipolar, these incidents, the limbic system literally perceives these as life-threatening events. So, think of it this way. When a child has a plan in their head, maybe it's, I'm going to go home, I'm going to have a cookie, or I'm going to play a video game, and then I'm going to eat pizza for dinner. So that's the plan. But then when this child gets home and they find that his brother ate his cookie, he has to get ready to go to his sister's boring soccer game, and dad has made roasted chicken and vegetables for dinner.
So the plan that this child has made has been unexpectedly changed.
For that child, it's been unexpectedly changed, right? So dysregulation is going to occur because all that energy is going to take it just takes too much energy to really create this new plan for that kid. And so remember, if we're thinking about bipolar or mood disorders in general as an energy disorder, we're talking about the energy that is required to make adjustments and complete new tasks. And sometimes that energy just isn't available to do that. And the hippocampus is storing all of those great memories of the cookies, the video games, and the pizza. But when that gets changed unexpectedly, it requires this massive amount of energy to change with it. And if that child is in a depressive episode, they really don't have that energy to just pivot. And if in a manic or a mixed mood episode, as you can imagine, there can be an explosion of symptoms that could occur.
So when we look at this from the limbic system standpoint, we're seeing that the limbic system itself is being overwhelmed, and that is leading to symptomatic behaviors. But most often, the child is being perceived by the adults around them as spoiled or manipulative because they're acting out, definitely in quotes, because they didn't, again, quote, get their way.
And unfortunately, you're right. It is perceived that sometimes they're exercising bratty behavior, right? But for that child or adolescent who lives with anxiety, depression, bipolar, fear of harm, PTSD, these transitions in the environment are a constant struggle of having to adjust. And it's extremely taxing on their limbic structures and also their brain and their body. And so we can see at this point that the limbic system plays a pivotal role in these observable symptoms of mood disorders. And understanding, Elizabeth, the physiological and the biological symptoms allows for really more effective and targeted interventions and treatments. And so it recognizes that first, the child or adolescent is experiencing a biological phenomenon versus really placing the onus of responsibility on the child and labeling it their behaviors as purposeful. It relieves the burden of parents and professionals to find more appropriate consequences, that they don't have to find actually appropriate consequences or punishments. We're free from that because it allows for more of a compassionate and also a collaborative approach to resolving these what are symptoms.
Yeah, Jen, and you and I both know from our work and teaching our palliative parenting class, that parents and teachers, we're all taught that the way to help a child regulate themselves, the way to help a child behave appropriately is to administer some sort of consequences, right? That's the terminology that people use nowadays for, but it really just means punishment, right? That we're going to impose some sort of discipline on a child in order to teach them not to do that behavior again. But you and I know that doesn't work, right?
Yeah, and we hear that over and over again. So even though it's really tempting to give consequences or punishments to children when we observe that they're making what we consider poor choices, um, or they're exhibiting disruptive behaviors. But Elizabeth, would you give a child who is a diabetic and experiencing a low blood sugar a consequence because they yelled at their teacher when they were experiencing a low blood sugar? And the answer is, of course not. Most of us, and in fact, pretty much, I think I would hope all of us across the board would agree that that would be highly inappropriate and really not productive in meeting their medical needs. So clinicians can identify the biological and neurological symptoms and assist in helping people to understand the appropriate interventions.
Jen, and I love how you use the term, medical needs when you're describing a child who has low blood sugar. And part of what we're talking about here is really understanding and reframing our understanding of what we see as, quote, behaviors as truly medical needs. Because what is happening to them is not an intentional behavior that they are engaging in order to intentionally have an impact on their environment. They're experiencing a dysregulation in their limbic system. They're experiencing a dysregulation in their brain that has an involuntary outcome, which is involuntary symptoms that they're experiencing, not behaviors. And again, this is something that we talk about over and over again in all of the work that we do, in allowing ourselves as clinicians, allowing ourselves as parents to free ourselves from this, from the bounds of having to think about everything in terms of behavior that can be molded. And that when we understand the limbic system, we understand that we can't simply mold change in these biological structures by offering a reward or a consequence. And so that is where we're going to stop for today. We want to share a few more pieces of information before we go into the Q&A and start addressing the questions that haven't been answered. But first, we want to share with you 2 slides that include all of the works that were used in the development of this presentation. And so I want to remind everyone that part 2 of this series on the limbic system will take place on the next month in November on Wednesday, the 20th. That is the week before the week of Thanksgiving, so a regular old work week for us. So we hope to see you for part 2 on November 20th, 2024, when we talk about how we can take this understanding that we now have of these limbic system structures and turn that knowledge into actionable actions that we can take to support de-escalation and re-regulation in times of crisis. Again, if you enjoy our free webinars and clinical seminars, now is the time to make a gift to CMHRC to support our work during our fall fundraiser, or really any time of year you can make a gift on our website at cmhrc.org/donate. So now we're going to switch over to the Q&A portion of our event. And we are going to keep that private. If you would like to attend Q&A sessions or hear the answers to the questions that are asked, please make sure to join us for all of our live events, as now we are going to reserve this time just for the live attendees.